The chamber pressure looked perfect. Operators believed the face was safe, but underground, the soil was already collapsing. So how does a tunnel collapse? When pressure says everything is normal, let's look at the illusion of safety. In an earth pressure balance TBM, the entire tunnel depends on one thing: maintaining balance at the tunnel face. The chamber pressure must exactly balance the earth and water pressure outside. If pressure drops, the ground moves, and once the ground starts moving, collapse begins. This is where the most dangerous illusion in tunneling begins: fake pressure. The pressure sensor only measures pressure where it touches material, not the actual support across the entire tunnel face. So operators see normal pressure while the face is already losing confinement, and by the time the machine detects the truth, the collapse has already started. At first, the movement is microscopic. Small soil particles begin flowing toward low pressure zones. No alarms, no visible danger. Then the soil arch starts breaking. Tiny voids form above the cutter head. In mixed ground, this happens extremely fast. Once groundwater finds a pressure imbalance, it accelerates everything. Water removes fine particles and the ground loses strength, and the face begins unraveling. The collapse propagates upward from the tunnel crown to the street above. Understanding this progression is the first step in prevention. Next, we'll look at the specific technical causes behind these failures. First, screw conveyor imbalance. If operators extract spoil too quickly, support pressure disappears before the chamber can recover. Second, conditioning failure. When foam fails, the soil loses cohesion and stops transmitting pressure evenly. Third, mixed ground. One side remains stable while the other starts flowing, creating localized instability sensors can't always detect. Water ingress and over-excavation are the final mechanical triggers. If extra voids aren't filled immediately, the ground begins migrating. But many collapses are caused by decisions. Sometimes operators trust the screen more than the ground. Now that we know the causes, let's look at the critical warning signs every engineer must recognize. Warning sign 1. Pressure oscillation. Stable pressure should behave smoothly. Rapid oscillation often means unstable soil flow. Warning sign 2. Abnormal screw torque. Sudden torque changes indicate inconsistent material behavior inside the chamber. Warning sign 3. Increased surface settlement. The surface often warns engineers before the face fails. Warning signs 4 and 5. Changes in foam consumption and unexpected water inflows can signal major instability ahead. Recognizing these signs early is the only way to prevent a total disaster. Next, we'll see the moment engineers realize a collapse is in progress. When a collapse starts, the atmosphere in the TBM control room changes instantly. Radio chatter spikes as sensors across the machine begin to conflict. Geotechnical engineers report losing the crown, while the operator's screen still shows stable pressure. This is the moment of truth. Shift managers have to recognize that the pressure is fake. The order comes down: stop advance immediately. Every second counts. Once the machine stops, the battle to recover the face begins. Next, we'll look at the emergency response methods engineers use to stabilize the ground. When a collapse is detected, the machine stops immediately. Recovery method 1. Stop advance. Every second counts to prevent further migration. Second, rebuild pressure. Engineers use conditioning agents and controlled chamber filling to restore the necessary confinement. Third, grout injection. High-pressure grouting stabilizes voids before the settlement can spread upward to the surface. Finally, in severe cases, engineers may use ground freezing or dewatering to physically lock the soil in place and reduce groundwater pressure. These recovery methods are the final line of defense. Next, we'll wrap up the series with the most important lesson in tunneling: recognizing the ground's warnings. A tunnel collapse rarely happens instantly. It begins silently, with tiny pressure imbalances, invisible voids, and decisions made under pressure. In tunneling, the ground always gives warnings. The question is, will engineers recognize them in time? If you want real tunnel engineering breakdowns, TBM failures, and mega machine documentaries, subscribe now.